Hello, everyone. I want to talk about Antarctica and how it's responding to climate change and what that means for its contribution to future sea level rise. Is there a safe landing place from a climate futures point of view for the Antarctic ice sheet? And what does 1.5 degrees mean for the Antarctic ice sheet? So there it is, 70% of the world's fresh water, 90% of its ice, and 60 metres of global sea level rise if it all melted. So global sea level rise is the clearest planet-wide signature, if you like, of climate change so far. We've had 20 centimetres since the Industrial Revolution, and we're seeing an acceleration in the tide gauge record, the average tide gauge and satellite record you see in front of you. We are also seeing an acceleration in the mass loss of the polar ice sheets as measured from satellites. And you can see the blue line on the right, that's Greenland melting at a greater rate than Antarctica. And you can see Antarctica melting. The hotspot, of course, in Antarctica is in West Antarctica in that Amazon Sea region. And many models show that West Antarctica may be the dominant contributor, or at least the Antarctic ice sheet may be the dominant contributor by the end of the century. So currently polar ice sheets are contributing a third to the observed sea level rise, ocean thermal expansion a third, and the lower latitude and mid-latitude glaciers another third. But the polar ice sheets are jumping into the driver's seat, and the Antarctic ice sheet has the potential to really contribute very, very quickly to global sea level rise. So a couple of points that I'd like to make. Firstly, we can't avoid ongoing sea level rise, and the latest IPCC report shows that. The amount and rate of that future sea level rise will be determined by our emissions pathways in the future. What we can say for sure is that we're committed to 30 centimetres by mid-century or 2060 based on the heating so far. The Paris scenario, the blue scenario, will keep sea level rise below 50 centimetres. If we continue business as usual, we'll get around about a metre and maybe more by the end of the century. But concerningly, those pathways really diverge after 2100, and we end up with multi-metre sea level rise if we don't achieve the Paris climate target. Now, the Antarctic ice sheet is the other factor that will determine the rate of future sea level rise and the amount of future sea level rise. It's very different than Greenland. It sits largely grounded below sea level, 20 metres of equivalent sea level rise, a third of the ice sheet sit grounded on bedrock below sea level. The ocean is warming, 90% of the heat from global warming has gone into the ocean, and the majority of that into the Southern Ocean. And the Southern Ocean, which is warming, is in contact with the edges of the Antarctic ice sheet. So we know that ocean dynamics are incredibly important, and that the Antarctic ice sheet could respond in a non-linear and very rapid, potentially irreversible fashion. But we did not know enough to include Antarctic ice sheet dynamics into the AR5 report in the sea level rise projections. So the ones I showed you, even in SROC, largely leave Antarctic ice sheet dynamics out. There's a small contribution. So what have we learned in the last 10 years? What are the key rate determining processes? We know ocean dynamics matter. We know where the ocean is warming the most and interacting with the ice sheet. The ice sheet is melting the fastest, and we see that along West Antarctica and in the Amazon Sea region. We see the ice shelves are capable of very rapid melting and collapse, and the ice shelves are very important. They're the apron around the ice sheet where it flows out onto the ocean, and they play a stabilizing role, holding up the ice sheet, slowing its rate of flow down, much like Gothic Cathedral with its flying buttresses I'm showing there. Take away the buttresses, the cathedral falls down, similar to the ice sheet. So we know the ice shelves are important, and they can collapse and disintegrate very quickly. And we also know now that an ice sheet, once it starts retreating into a deep marine basin, can retreat in a non-linear, very fast and potentially irreversible fashion. So these processes, the physics around these processes, is now being incorporated into the latest generation of ice sheet models. And the picture they are painting is quite disturbing. We seem to have seriously underestimated for the RCP 8.5 scenario the contribution of the Antarctic ice sheet, which could be tens of centimetres up to a metre more than in the current IPCC reports. Certainly by the end of the century, and then 15 metres or more beyond 2500. The good news story is that the Paris scenario and an RCP 2.6 pathway limits melt from the Antarctic ice sheet. The ice shelves stay largely intact and the mass loss is limited such that global sea level generally stays below a metre. You can see on the left the two scenarios, they were just playing out in front of you over 500 years, and you can see the 8.5 loses much of the marine-based ice around Antarctica. So 1.5 to 2 degrees appears to be a tipping point for the ice shelves. They go, and the marine-based parts of the Antarctic ice sheet melt very rapidly. So an overshoot of the Paris target of the RCP 2.6 scenario could result in multi-generational commitment to many meters of sea level rise. So to avoid that, 50% by 2030 is the pathway we need to be on. It lowers the risk considerably and will prevent some of the worst impacts of sea level rise. So I just want to end on this final sobering note. Yes, we can still achieve a 2 degree world or less than 2 degree world without overshoot. But even if we do, we're going to get 30 centimetre sea level rise by 2050. That means the 100-year coastal flood for most cities in the world, most coastlines, will become an annual event. It also means that we'll get 50 centimetres by the end of the century. We can't really avoid that. So we are going to need to adapt. There are 700 million people who will be exposed to high tide flooding, even if we achieve the Paris target. And by mid-century, 18 million Bangladeshis could be displaced. So the take-home message is mitigate, don't overshoot, but also adapt. Thank you very much.